In this video, we're going to look at how to do quadratic and cubic regression on the TI-84. In this example, we're told that gas mileage is tested for a car under different driving conditions. At lower speeds, the car is driven in stop-and-go traffic. At higher speeds, the car is overcoming more wind resistance. The variable x given in the table represents the speed in miles per hour for a compact car, and m of x represents the gas mileage in miles per gallon. Use regression to find a quadratic function to model the data, round to the nearest 10,000th, 100th, and 10th, respectively. So the first thing that's important to note here is that they're looking for a quadratic function. So that means we want a function that looks like this: y equals ax squared plus bx plus c. That's what a quadratic looks like. Okay, so we're looking at the TI-84 here, so let me pull that up. And what I want to do is go to Stat, Edit. If you have any data in your list, go ahead and highlight the list using your up arrow, click Clear, Enter. I'll go over to list 1, highlight it, do Clear, Enter. And now I'm going to go ahead and type in the x values in list 1 and the y values in list 2. So list 1 is 25, 30, 35, 40, 45, 50, 55, 60, and 65. Go over to list 2 and put your y values: 23.5, 25.8, 28.7, 31.6, 32.7, now 31.7, 29.2, 24.9, and the last one, 22.7. Double check to make sure that you've typed everything in correctly, because mistyping even one number can mess up the whole equation. So let me double check this. All right, once you've got that in there, let's turn on our plot. So I'm going to go to y equals, go up to highlight plot 1 and hit enter. That will turn plot 1 on. For my window, I want an x value that's less than my lowest x value, so I might do 20. And an x maximum that's highest than my highest x value in the table. So my highest in the table is 65. So I'm going to pick a 70. So I'm going to go from 20 to 70 for my x, and I'm going to do a scale of 5. For the y minimum, I want to look for the smallest y in the table, which happens to be 22.7. So I might do 20 for my y minimum. The highest y value is 32.7. So for my y maximum, I'll do 35. And let me go ahead and hit graph now. So I've got the scatter plot. That's how you get the scatter plot. To go back to my home screen, I'll do second mode. And now to get the regression equation, I want to go to Stat. Use your right arrow to go to Calc. And we want number 5, quadratic regression. So I'll hit number 5. I have my data in list 1 and list 2. And then I calculate. So it gives me the coefficients A, B, and C here. So all I have to do now is write them down. So I will have y equals negative 0.02, let me pull that back up, 0.236. And that's attached to x squared. Now, the reason I went to 4 decimal places is it said round to the nearest 10,000. For the b value, I only need to round to the nearest 100, which is 2 decimal places. So let me come back to my calculator here. I'll have 2.11, and it's a positive, so I'll do plus 2.11x. And then the next one is the nearest 10th. So if I come to my calculator, I get C is minus 15.2. Now, if you want to see the graph of that along with your scatter plot, you would just come back to the calculator, you would go to your y equals, and you would put in that equation just like we wrote it down. Now we can see that this is going to be a parabola because it's a quadratic, and we know that it will open downward because of that negative leading coefficient. So we know that it's a parabola opening downward like this. And so the next part of the problem makes sense when it says at what speed, it's asking what is the x value, because remember x is the speed, is the gas mileage the greatest. So at what speed is y the greatest? So on that parabola, we're looking for the maximum value. And the maximum value, if our parabola opens downward, is going to be at the vertex. So we know that for the vertex, that x equals negative b over 2a. So this is how I would show my work for this part of the problem. So b is 2.11, so I'll have negative 2.11 divided by 2 times a, where a is negative 0.0236. And I just have to put that in my calculator. So I'll put negative 2.11 divided by parentheses 2 times negative 0.0236. And they say round to the nearest mile per hour. So 44.7 would round to 45. I'm going to go ahead and put 45 miles per hour is when the gas mileage is the greatest. And now they want to know what is the maximum gas mileage. And remember, gas mileage is y. And so I'm going to have y equals negative 0.0236 times 45, because that's the x value we found for the vertex. So times 45 squared plus 2.11 times 45 minus 15.2. And again, I come to the calculator. I'm going to go ahead and just put that in, negative 0.0236 times 45 squared plus 2.11 times 45 minus 15.2. And they say round to the nearest mile per gallon. And so that would round 31.96 would round to 32 miles per gallon. All right, so that was the quadratic model. To find a maximum or minimum, you're just using the vertex formula that we've used before. Now let's look at a cubic model. Let me pull this up and clear out what I have so far. This says for a certain individual, the volume in liters of air in the lungs during a 4.5-second respiratory cycle is shown in the table for 0.5-second intervals. Graph the points and then find the third-degree polynomial function to model the volume v of t for t between 0 seconds and 4.5 seconds. Hint, use a cubic regression option or a polynomial degree 3 option on a graphing utility. All right, just like with the quadratic, I start out at stat, edit. To clear my list, I highlight it and do clear enter. Highlight, clear enter. In column 1, I'm going to go ahead and enter my x's. I have 0, 0.5, 1, 1.5, 2, 2.5, 3, 3.5, 4, and 4.5. For my y's, I have 0, 0.11, 0.28, 0.47, 0.63, 0.76, 0.80, 0.74, 0.54, and 0.1. All right, now first thing we want is the scatter plot. So I'm going to go to the y equals, make sure plot 1 is on. For my window, I want the x minimum and x maximum to kind of encompass all these x values. So if I do a minimum of 0 and a maximum of 5, that will encompass all the values from 0 to 4.5. And I'm going to make my scale 1. For the y's, notice the smallest y is 0 and the largest y is 0.8. So I might do like a 0 to 1 for y. And maybe a scale of 0.1, 0.1. And I go to my graph, and I should be able to match that up pretty well. I know my highest value needs to be that 0.8. So that one's not it. That highest value is 0.6. This highest value is 1. This highest value is too high. Graph A looks perfect. It matches what I have on my calculator, and I can see my maximum y value is at 0.8. I have that 0.00, so I know that's the correct one. All right, now they want the cubic regression. So second quit to go to your home screen. Go to stat, out, and we want a cubic regression. That's degree 3. So I'm going to select number 6. Make sure the correct lists are here. List 1 and list 2 for me. And then do cubic regression. We get ax cubed plus bx squared plus cx plus d. They say round to 4 decimal places if necessary. So over here, I'll put in negative 0.0409. And I have to do x cubed. Actually, this says v of t for t between 0 and 4.5. So I better put a 2 there. Otherwise, it will give me an error. And then my b value is 0.1550. That'll be t squared. C is 0.1718 T, and then D is minus 0.0037. So make sure all your rounding is good. Make sure you're using the correct variable, and that's how you do cubic regression.